All right, we are recording. Good morning, everybody, and welcome to the last part of 2014. We're going to be doing numbers 5 and 6 today. Go ahead and tell you number 5, definitely mandatory area function. I can see this being on there. Number 6, the Taylor series. Now, remember how they cut the Taylor series? They took a big chunk of it out. Number 6 for 2014 in particular. I can't see any of those topics being something you'd be tested on. I'm still going to go through with it, but as far as your work is concerned, I'm okay with your attempt not being, you know, all the way through. You can just copy the video and just kind of make note of it for a little bit of review there. I still would like you to complete it. Um, it is a good problem. Part A of number 6 could be good practice. It's not the full extent of what you need to know, but it does practice using the ratio test, which is something that's on our curriculum. So, but anyway, let's go ahead and go through number 5 here. Let's start with A. So it says R be the shaded region bounded by the graph of x e to the x squared, which is that top curve, the line y equals negative 2x, and the vertical line x equals 1 as shown in the figure above. All right. So if I want to find the area of R, we've done this before. We got our left bound and we got our right bound right here. So it's simply going to be the integral of the top function subtract the bottom function, right? So if I want to find this is going to be the integral. Now my left to right bound is simply 0 to 1. It tells me that in the problem. And the top function is that x e to the x squared, and we're going to subtract the bottom function, which is that negative 2x. All right, so there's the area function, which we can change this to plus 2x if you want to. Minus a negative makes it plus. We're going to integrate each of these and plug in 1 and 0, and we have our answer. Okay. If we're integrating this piece right here, you notice we have x squared in the quantity, and I'm sure some people recognize we can do x squared for u and do du to be 2x, which that x and that x cancels out, and we got a 1/2 that comes to the other side. Okay, so this is simply going to be 1/2 e to the x squared. Okay, and you can, I mean, let's just use substitution, um, and yeah, so you can test that, make sure that's the correct integral. If you want to derive that, test it, you can, but that is correct. And then the integral of 2x is just x squared, and we're evaluating this from 0 to 1. Okay, if I plug in 1, I get 1/2 e to the 1's power is just e, and then plus 1 squared is 1, and then minus. If I plug 0 into that power, that just becomes 1 times 1/2, and then plus 0 squared is 0. So that's what we're left with. I think it's fine if you leave it that way, but it does simplify down to 1/2 e plus 1/2. And that is what I got for my final answer. Okay, so nothing too terrible. It's just a generic area problem, top minus bottom. Okay. All right, what about B? B, I love it when it says this. Write but do not evaluate. Oh, love that. Write but do not evaluate. An integral expression that gives the volume of the solid generated when R is rotated about the line y equals negative 2. Y equals negative 2 is below the y-axis somewhere over here. Just to be sure, it doesn't intersect anything prior to this point here. I'm just going to plug in 1 into this function just to see what that intersection is. So y equals negative 2 times 1, which is equal to negative 2. So this point right here is actually on the line negative 2. So if I draw that line, it falls perfectly on that point. Okay, so that works out pretty good. All right. Okay, so if you notice, so what we're doing is we're taking this shaded region and we're rotating it about this line. Try to visualize what that three-dimensional figure looks like. Most importantly, recognize that there's going to be this big old gap right here. Okay, so if that's the case, then this is the washer method. Okay, because we're going to have like that hollow area in the function as it's being rotated. So with washer method, remember how this works. It's going to be still pi r squared, so pi integral a to b, okay, of your bigger radius, your outside radius, squared. So I'm going to say that's like, I'm going to call that capital R squared minus, and then lowercase r squared. So it's the bigger radius squared, subtract the smaller radius squared, okay, dx. So in the context of this problem here, I'm setting it up. It's going to be pi integral, a to b is still 0 to 1, okay? And my big R here, my outside radius, the one that's farthest away from my line of revolution is this exponential piece. That's my bigger radius, okay? So that radius is equivalent to the function, which is x e to the x squared minus my line of revolution, so minus -2 quantity squared. So that's my bigger radius squared, subtract my smaller radius squared, which was that -2x, and then minus -2 again, the line of revolution, quantity squared. All right. So there you have it. There's the integral that represents that volume being generated around the line y equals -2. All right, let's move on to C. If you did not get C your initial time around, do not stress, because this is involving stuff from Unit 9 that we're no longer being tested on. So let's talk about what it means. You'll see. So it says write, but do not evaluate. I still like that part of it. An expression involving one or more integrals that gives the perimeter of R. Okay? The perimeter of R. And I want to go ahead and clarify, if this says one or more integrals, that doesn't mean the entire thing has to be integrals. It just means you got to have some integration in there. Okay? So perimeter, what perimeter means is we're going to take this length, we're going to add it to this length, and we're going to add it to this length. We're adding 3 lengths together. If you notice, it's 2 lines and 1 curve. Now the 2 lines we don't need to do any fancy integration with, because those are just lines. We just count up how tall they are or how big they are. Like for instance, let's do this curved line right here, -2x. Like how long is that line right there? Well, if you remember from part, I think it was A when I said it, this point right here is at 1, -2, which is definitely not drawn to scale. So that means that like the height is -2, the length is 1 right here. So if I simply do Pythagorean theorem, do -2 squared plus 1 squared equals c squared, that ends up giving you, I think, the square root of 5. So the length of that curved line is the square root of 5 plus. Now what about the length of this vertical line? Okay. Well, I know this value right here is at -2. Well, what's the y value here at the top of it? Then simply it's just the difference between the two. And that's found by plugging 1 into this function, which is 1 times e to the first power, or simply e. So the length of this line is e minus -2, or simply e plus 2. So we got the length of the slanted line, we got the length of that vertical line, and now the last part that's going to involve my integral is how do I figure out the length of this line here? Well, a length of a curve, that's arc length. Now if you remember what arc length is equal to, okay, arc length is equal to the integral a to b, all right, of the square root of 1 plus f prime of x quantity squared. Okay, so all we need for this is just to have pretty much what f prime is, and this is my f function, I guess, in this case. So y prime is equal to, that's product rule, so the derivative of the first is 1, keep the second the same, plus keep the first the same, and then the derivative of e to the x squared is ex squared times, chain rule here, 2x. Okay, so there's our derivative. So if I want to set up the length of this of this arc here, we're going to go plus integral, it's still 0 to 1, square root of 1 plus f prime squared. F prime was ex squared plus 2x squared e to the x squared. When you simplify it, quantity squared. Okay. And that's my answer. That's the setup. I got the 3 different links being added together. Okay. So if you got A and B, you're good. C, you still could definitely have the ability to get it. It's just now we're no longer required to know arc length because that was in that Unit 9 that they took out. Okay. So that's number 5. Let's look at the answer key. Make sure we did everything right. So for A, we got the integrand. Okay, we got the correct setup, top minus bottom. We took the correct integral, and we got the answer. We wrote it as 1/2 e plus 1/2, but that's still the same thing. Okay. 2 points for the integrand for letter B, which we got. We got the outside radius squared minus the inside radius squared. We did that. The limits and the constants are all good. For C, the fact that we got the correct derivative, which they took out a GCF of ex squared from the derivative. Our derivative had that distributed through, which is fine. They had the correct integral expression for arc length, and then the answer, which included the lengths of the other 2 lines. Okay. So you have that was number 5. I don't think that one was too terrible. Let's move on to number 6. Okay. So number 6 is a little bit of a doozy. All right, let's see. A, B, C. So they're all these problems are kind of not in the curriculum anymore for our little quarantine thing we got going here, but it's still a good problem. I think A is something that you could definitely do. Yeah, let's just go through with it. Okay, let's see how you did. Hopefully you tried it on your own. So 6 says the Taylor series for a function f about x equals 1. So we got a Taylor series centered at x equals 1 is given by. So they went ahead and gave you the general term here. They didn't have it written out, so that's good. Everything's written out for you. And it's already telling you that it converges for some bounds less than r, where r is the radius of convergence for the Taylor series. Okay, remember that it converges whenever we have the absolute value of x minus a. Okay, so my center, and then the radius of convergence is just the quantity that it's bounded between. Okay. All right. Well, it wants me to find the value of r. It wants me to find that radius of convergence. Now, we have a particular way that we find the radius of convergence. Okay, we learned that is found by doing the ratio test. So even though no longer is the ratio test to find the interval of convergence on our final exam, they still have the ratio test as just a way of determining if it converges. So no x, just all n. They have that still as a topic, so it's still a good idea to practice this. Okay. So for instance, let's see. The ratio test is the limit as n approaches infinity, absolute value of a sub n plus 1 divided by a sub n. Okay, so let's go ahead and plug all that in. So we're going to have the limit n approaches infinity, absolute value of a sub n plus 1. Now remember, absolute value is going to get rid of and eliminate that alternating series piece. Right? So we're not going to worry about that. So everywhere else, we're going to plug in n plus 1, n for n. So that's going to be 2n plus 1. It's going to be x minus 1 n plus 1. And on bottom, we're going to have n plus 1. So that's everything with the n plus 1 plugged in. Okay. And we're going to multiply that by, because we're going to do same change flip, a sub n. Okay, so that would be quantity n on top, and on bottom 2n and x minus 1n. Okay. Cool. Now all we gotta do is simplify and take the limit. Okay. So remember how we simplify with these, like 2n and 2n plus 1 simplifies to 2 right here. It's 2 to the first power. Same thing with the x minus 1 to the n plus 1 and x minus 1 to the n simplifies to x minus 1 on top. Okay? And then the n and the n plus 1 is nothing cancel there. So what this simplifies to is the limit n approaches infinity, absolute value of 2x minus 1 times n over n plus 1. Okay. Now remember, we're trying to solve for r. And r is in this form right here. We're trying to solve for that radius of convergence. Okay. So let's go ahead and take the limit. Now when I'm taking the limit of n, remember, we do our n behavior rules. That's n to the first, n to the first. We take the leading coefficients, which is 2 times x minus 1 over 1. So we have that this limit is equivalent to, okay, absolute value of 2 times x minus 1, okay? And that is we're trying to figure out the radius of convergence. That's going to converge whenever we're less than 1, okay, based off of the ratio test. So if I'm trying to solve for r in this quantity f right here, all I have to do is get x minus 1 by itself, okay? So the absolute value of 2 is 2, so I got 2 times absolute value of x minus 1 less than 1. And now all I got to do is divide by 2. So I got absolute value of x minus 1 is less than 1/2. So when it's centered about x equals 1, the radius of convergent is between 1/2 and negative 1/2. Okay, so that's my radius of convergence. Simple enough. Okay, cool. And that's price and ratio test. So I think that's still a good problem to do, good problem to try, and we should be pretty good with that. Okay. All right. Now these next two can be a little bit of a stretch, so not gonna be the worst thing in the world if you don't get these, but we'll still try them. Okay. The Taylor series. The Taylor series. So I still got that. All right. Now we're finding the first 3 non-zero terms and the general term for the Taylor series of f prime, the derivative of f, about x equals 1. All right, this one's actually not that bad because we're given the series for f. All it wants is the series for f prime. It's simply taking the derivative. So if I want the derivative of the first 3 non-zero terms, let's figure out the first 3 terms of this series and then take the derivative of that, and that's it. Okay, so let's start with just f. Okay, let's start with f. So how do I get the first 3 terms? Well, I'm starting off at n equals 1 in my series, so all you have to do is plug in n equals 1, n equals 2, and n equals 3, n for n, and write out those 3 terms. Okay, and I kind of did that. I'm gonna do that on scratch work here, and so can you. But okay, so if I plug in say 1 everywhere for n in this series, what's that first term? Well, the 1 is gonna give me a positive number for the alternating series part, and when I plug 1 in for everything else, you get 2 times x minus 1. Okay, again, you can try that yourself. Now, if I plug 2 into that, that's gonna make us have a negative term. Okay, for the 2 to the n, we're going to have 4. For the denominator, we're going to have 2. And that's going to be x minus 1 to the second. Okay. And then if I plug 3 into that, we're going to go back to a positive term. It's alternating series. I'm going to have 2 to the third, which is 8 over 3, and then x minus 1 to the third. So that's if I plug in my first 3 terms. This is just f. And remember that the general term is that quantity negative 1 n plus 1, 2 over n x minus 1 to the n. Okay, so that's simply what f is. I need f to figure out f prime. Now f prime is just going to be the derivative of all this, and then that's our answer. Okay. So if I take the derivative of 2 times x minus 1, that's just going to be 2. Okay. If I take the derivative of this quantity here, doing power rule, that's just going to be minus 4 times quantity x minus 1. And if I take the derivative of this quantity, that's going to be plus 8 times x minus 1 squared. Okay. And then plus dot 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 plus. Okay. And if I want to know the derivative or the general term of my derivative, I'm just going to take the derivative of this. And all it was power rule, right? This negative 1 is not affected. That's just my coefficient. So if I do power rule and bring n down, the n's are going to cancel. So I'm left with negative 1 n plus 1. The n's cancel, so I'm left with 2 to the n. And I got x minus 1 to the n now minus 1 power. And that's your derivative of f. And that's the first 3 non-zero terms. So that wasn't awful. All we did was just take the derivative of it. That's it. Okay. So there you have it, the function and the first derivative. All right. Now, and then lastly, C. So C is okay. I think A was doable. I think B was actually pretty doable once you kind of knew what I was asking. I think C was probably the most difficult one. Yeah. So we're gonna try our best to comprehend this. Okay. It says the Taylor series for f prime about x equals 1, which we found in part B, okay, is a geometric series. Okay. I'm sure we could have figured that out by looking at the pattern eventually, but it's telling us it's a geometric series. Okay. Now there's certain properties that comes with a geometric series. It wants me to now find the function f prime to which the series converges to the absolute value of x minus 1 less than r. And we're going to use this function to determine f for the same interval of convergence. It's kind of a fancy way of saying something easy, I think. Okay. Now, if we have a geometric series, that means that our pattern has a common ratio. Okay, that's the first thing that we need to note. And also, if we have an infinite geometric series that converges, the function that represents that series that we've talked about so many times, all right, if I want to represent f prime of x as an actual function, and if it's a geometric series, we have a way to do that. It's simply a sub 1 over 1 minus my rate. Okay? That is a function that represents an infinite geometric series that converges. Okay? So all I need is this value and this value. Okay? That's all I need. So if we look back at what we found earlier, we're talking about f prime. We're trying to create a function for that. Here is my a sub 1. That's my first value. Okay? If I wanted to know my common ratio, all you have to do is take one term, let's say negative 4 times x minus 1, and divide by the previous term, which we'll say is 2. Okay, and that'll tell me a common ratio, which in this case would be negative 2 x minus 1. Okay, so in this problem, r is equal to negative 2 times x minus 1, and a sub 1 is equal to 2. We found that from part B. Okay, so the function that is represented here, okay, the function that is represented here, I'm trying to remember, f prime of x is equal to 2 over 1 minus the quantity negative 2 times x minus 1. That is the function that represents our geometric series, because we know this is true whenever a geometric series converges. Okay, and that actually simplifies down to 2 times. Let me make sure I say this right. My computer was being dumb again. Sorry. 2 times 2x minus 1. Okay, that simplifies down. So that's my function. That is what f prime of x equals. Now that only equals that whenever it converges. And that radius of convergence, remember, we find that by taking our rate and doing the absolute value of that less than 1. Absolute value of negative 2 is 2. So remember the radius of convergence was 1/2, which we already found in part A anyway. So the derivative is going to have the same radius of convergence. So anyway, this is only true during that. So we got f prime of x on that radius of convergence, which I didn't need to find that radius of convergence again because it's the same radius of convergence, but we just showed it again. Okay. And now we're going to use the f prime to find what f is, the function for what we started with on the same interval. So if I got f prime, if I want to know what f is equal to, it's simply going to be the integral of f prime, or the integral of 2 over 2x minus 1 dx, which I can integrate all day long. You can let u be 2x minus 1, and du is going to be 2 dx, which that and that cancels. So really it's just the integration of 1 over u, which is going to be equal to ln absolute value of 2x minus 1 plus c. Okay, there you go. So we got f. Now, really the only thing left that we have to do is figure out what quantity c is. And honestly, guys, it's not the hardest thing in the world. You got to think of some value that you can plug into this series right here that we know the y value of. And I recommend plugging in 0. Or I'm sorry, I recommend plugging in the center. I always recommend plugging in the center. Like if I plug 1 in for x, that's going to make this rate 0, and that's going to converge to 0. So basically what I'm saying is f of 1 is equal to 0. F of your center is always going to equal 0. So if I do that, and I set that equal to 0, I can do like ln of absolute value of 2 times 1 minus 1 plus c equals 0. This becomes the ln of 1 plus c equals 0. ln of 1 is 0, so c is 0. So my final answer here, and I'm going to write it in the top corner. Well, I'll write it right here, I guess. F of x is equal to ln absolute value of 2x minus 1. Okay, there you go. I think A and B were doable. C, I think the wording was just a little bit confusing, but if it tells you it's a geometric series, that's just, there's common things that come with that. And we know we have a common ratio. We know that this is what represents the function. And we can kind of go based off of that. All right. Just to look at the answer key here, make sure we're all good. We set up the correct ratio for part A doing the ratio test. We figured out the limits of the ratio, okay? And then we determined the radius of convergence. So we got down to 1/2 for that. And we got 2 points for finding the first 3 non-zero terms, and we did that by finding the first 3 non-zero terms of f and then taking the derivatives of each of those. And then we found the general term by taking the general term's derivative. We didn't specify that it was for whenever n was greater than or equal to 1. I guess you can maybe make that note if you want to. And then lastly, we figured out the correct derivative to be 2 over 2x minus 1 using the fact that it was a sub 1 over 1 minus r. We took the correct antiderivative, which we got ln absolute value of 2x minus 1. We solved for c, which was 0, and got f of x. Okay. That was a tough problem. I'll give you that. That was definitely a tough problem. I think A and B we could have reasoned through. I think C was just a little bit tougher. So it's okay if you didn't get that. But there you have it. So that was the rest of 2014. So maybe I would prefer you take notes for number 6 if you don't mind. And we will discuss how to turn these in later on throughout the week. But for now, just keep running tabs, keep all these together in a folder, and you'll be good to go. So good luck, guys. Let me know if you have any questions, and I will talk to y'all soon. Under 30. Here we go.